All right, this is the video to review for the semester 1 exam. This is not the exact same review as you got on paper. These are similar problems. So hopefully if you get stuck on like number 7 on the paper review, that you can go back to this review and look at number 7, which is similar to it, and follow a similar process to find the answer. Okay? So let's just do this. Number 1. Rewrite the expressions as the product of two binomials. Okay, so the product of two binomials means I'm going to have to factor at the end, right? So binomial means two terms. So I'm going to factor at the end. Okay, so I'm first going to simplify this. So let's see here. I'm going to distribute the 3, and I have 12x minus 3 plus this x squared means times itself, and so that's x minus 1 times x minus 1 plus 23. Okay, the next thing I'll do is I'll expand or multiply and distribute these. This stays the same, 12x minus 3 plus x times x is x squared. X times negative 1 is negative x. Negative 1 times x is minus x. And negative 1 times negative 1 is a plus 1 plus 23. I will then combine like terms. Let's see here. I have an x squared. I have 12x minus x, which is plus 10x. I then have negative 3 plus 1, which is negative 2. Negative 2 plus 23 is plus 21. Okay, now again, I'm going to factor at the end. And so if I use the ATM method, the simplified ATM is what I call it. I know each teacher calls it a bit differently, and I'm going to stand off factors by grouping at this point. But anyway, you get to x plus 3 and x plus 7. I'm not sure what factoring method you want to use based on who your teacher is and what method they prefer. Because 3 times 7 is 21 and 3 plus 7 is 10. But that is the answer to this one. Again, it's different than the paper version, but that's kind of the process you use. You expand it out and then you factor. Number 2, rewrite the expression in its simplest form. Exact answers. Do not give a decimal approximation. So the first thing I'll do is I will multiply or distribute each of these. Root 8 times root 3 is the square root of 24. And the square root of 8 times 2 root 6, I will multiply the square roots together, but I will not multiply it by the whole number. I get 2 root 8 times 6 is 48. Okay, and then I'll multiply these two together. Negative 2 times root 3 is negative 2 root 3. And negative 2 times 2 root 6 is minus 4 root 6. I'll multiply the whole numbers together, but not the square root. Okay? Now at this point, I'll be looking at it, and I can do some simplifying here and here, but root 3 is a prime, and root 6 has no perfect squares that divide it. So I know that many of my students prefer factor trees or a t-chart. Let's do a t-chart. So 24, I'm looking to simplify that. So what is the lowest prime number that divides 24? The answer is 2. 2 divided by 20, so 24 divided by 2 is 12. 12 divided by 2 is 6. And again, the lowest prime that divides 6 is again 2. And it goes into 6 3 times. And then I have 3 and 1. Okay, now I'm looking for pairs, and I have a pair of 2's here. Because, well, let me back up. 2 times 2 times 2 times 3 is 24. And this pair means I have a perfect square of 4 that divides 24. And the square root of 4 is 2. The square root of what's left. And what's left is 2 times 3, which is 6. Okay? Now, to do root 48, I will still have the plus 2, that's this 2 right here, I have that 2, times root 48. So let's see here, let's go over here. This 48, the lowest prime that divides 48 is 2, and 48 divided by 2 is 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. And then the lowest prime that divides 3 is 3 itself. And then I have a pair of 2's and then another pair of 2's. Okay, so root 48 is equal to the square root of, let's see here, 2 times 2 is 4. The square root of 4 is 2. This pair of 2's down here, square root of 4 is, again, another 2. I'm multiplying these together, times what's left, which is 3. So I get 4 root 3. So let me go back over here. I have 2 times 4 root 3, minus, again, 2 root 3 minus 4 root 6. Okay. For the sake of space, I'm going to do something here without rewriting it. I'm going to 2 times 4 is 8. Okay, and now I will combine like terms. So if I combine like terms, I have, let's see here, 2 root 6 minus 4 root 6 is negative 2 root 6. And 8 root 3 minus 2 root 3's is negative 6 root 3. And I believe that's the answer. Okay, so again, the one on the worksheet, on the packet, you're again distributing, you are then simplifying, and then you're combining like terms. That's the process. Okay, number 3, we've got to remember some things about I and what I means. So don't forget that I is the square root of negative 1. That's not used directly in this problem, but it helps us know that I squared is the square root of I squared, which is negative 1. Okay, and know that I cubed is I squared times I, and I squared, remember, is negative 1, so we get negative I. I cubed is negative I. So this right here, this I cubed, is negative I. So I have negative 1/4 times negative I. Whoops. Don't know how that happened. Negative I. And then inside parentheses, I have the square root of negative 16. Now, the square root of 16 is 4, and the square root of negative 1 is I. So the square root of negative 16 is 4i minus 2 plus 5 times I squared, but remember the I squared is negative 1, so I have negative 1 there. Okay? So negative 1/4 times negative I is, let's see here, negative times a negative is a positive, so I have I over 4 times, I guess 1/4 I. I think most students have been happier with 1/4 I. This is still 4i minus 2. I have 5 times negative 1 is a minus 5. Okay. And the next thing I'll do is distribute this 1/4 I into this binomial. So 1/4 times 4 is 1. And so I get 1. And I times I is I squared, which is negative 1. I'm not sure that's too much in one step or not, but 1/4 times 4 is 1, and I times I is negative 1. Now, 1/4 I times negative 2. Now, 1/4 times negative 2 is negative 2/4 or 1/2, and the I is there, minus 5. Okay, now combine like terms to be in this form, the a plus bi form. Negative 1 minus 5 is negative 6, and then my minus 1/2 I. That's what it is. Okay, so again, just kind of simplifying very slowly, being very careful about I. Okay, number 4, I should have left that up there. Oh well. Number 4 is pretty simple if you know how to factor the difference of cubes. On the packet, it's a sum of cubes, but it's a very similar process. Okay. Now I know they do this a little different than the other Algebra 2 teachers, so I'll just explain it the way I do it. Okay. So the way you simplify this, it's the same pattern regardless if it's plus or a difference or sum of cubes. I think about what is the cube root of a cubed, and that's a. What is the cube root of -8? And that is 2, because 2 times 2 is 4, times 2 is 8, and so the cube root of -8 is -2. Now this next bit is a trinomial, and what I get is this number, a squared. I then do this number times this number, change the sign. So a times -2, change the sign, is a plus 2a. And then -2 times -2 is positive 4. Okay, that's the process for either sum or difference of cubes. That process works for either one. Now, if we compare this one up here and this one down here, the only difference is this m value, which means m, just kidding, negative m equals 2, which means that m must be -2. All right, that's number 4. Okay, number 5, Anthony stated that he had divided 3x cubed plus 6x squared minus 15x plus 5 by x minus 3 and determined that x minus 3 is a factor of the dividend. Determine if he is correct or not and explain how you know. Use complete sentences and correct terminology. Now, there are, I can think of 3 ways to do this, and I don't care which way you approach it, as long as you can explain how you know. Okay? The first way is you could use synthetic division or long division, okay? Because this is x plus or minus some number. So I'm going to do that. You could do long division. I'm not going to do that for the sake of time. But you could use long division to see if he's right. And then you change the sign from -3 to +3 so that when I do my synthetic division, I can just add and not have to subtract. Okay? I don't have any missing terms, so I'll pull off the coefficients. Okay, I'll do this kind of quickly because I'm doing all 3 methods here. And I'll explain this process, I'm sure, in another one. Okay, so the last number you get is the remainder. Okay, so if this was my approach, I would say, now I will just say it in words and not write it down, but I would say he is not correct because I have a remainder that's not equal to 0. Okay, I don't have my pen to change colors. There it is. Okay, the other method you could use is using the remainder and the factor theorem. I could plug +3 into the polynomial to see what remainder I'd get. That's probably 95, but let's do it this way. I made a mistake right here. And I get 95. Okay, and I would say, writing things down, I would say by the remainder theorem, if I divided those, I'd have a remainder of 95, which is not 0, so it can't be a factor. Okay. The last way, maybe it's the simplest way, is that if it did divide, then it'd be x plus x minus 3 times some polynomial which would be equal to this one right here. 3x cubed plus 6x squared minus 15x plus 5. Now the point is that that means that this last term, that negative 3 times something, that last term in this polynomial, whatever it is, would be 5. Now, the problem is that there is no number. I guess let me back up. So, 3 is not a factor of 5, that last term. So, x minus 3 is not a factor of the polynomial. Okay, I don't care which way you approach it, whether you use synthetic division to say, hey, no, here is what it is, and it doesn't divide it evenly, or the remainder theorem, or thinking about if the last terms are factors of each other or not. Okay, number 6. Given that x plus 1 is a factor of f of x equals 3x cubed plus 5x squared minus kx minus 7, determine the value of k. Well, knowing that it's a factor is a pretty important piece of information. Okay, again, the remainder theorem says that if I divide this function by x minus 1, then the remainder I would get is the same as if I plugged negative 1, again switching that sign, negative 1 into the function. Okay, the next thing is using the factor theorem. The factor theorem says that if it's a factor, then the remainder must be 0. Okay, so I'm going to put that equal to 0. I'm going to simplify over here a little bit. Negative 1 cubed is negative 1, so I have negative 3. Negative 1 squared is positive 1. Negative k times negative 1 is a plus k, minus 7. I'm now going to combine like terms. Negative 3 plus 5 is 2, minus 7 is negative 5, plus k. And I'll add 5 to both sides. Whoops. And I have k is equal to 5. All right, number 7, multiply 2x minus root 3 by its conjugate. Okay, the biggest question that students have with this one is, what is it meant by a conjugate? The conjugate is a useful tool that we have, and basically what it means is it's the exact same binomial, but you change the middle sign. Okay, and that has some nice properties that I'll talk about at the end of this problem. So I'm multiplying 2x minus root 3 times its conjugate, which is 2x plus root 3. Okay, so here we go. I'm going to distribute 2x times 2x is 4x squared. 2x times root 3 is plus 2 root 3x. Negative root 3 times 2x is minus 2 root 3x. And negative root 3 times positive root 3 is a negative root 9. Now notice right here is that this term and this term cancel, okay? And that is the power of the conjugate, okay? By having the exact same numbers but the sign being switched, that middle term will always cancel out. Okay, so I have 4x squared minus the square root of 9 is 3. Okay, and so I get this. Okay, again, the conjugate's powerful for radicals, for example, is because I can multiply it by its conjugate and get rid of a radical. That's useful like when with denominators and things like that. Anyway, number 8, if you're one of my students, I didn't really teach you this pattern. Really quickly, if you are one of Mr. Christian's or Ms. Stanoff's students, and you remember this pattern from earlier in Module 1, the pattern has to do with the fact that this is the same as this, and this is the same as this, and these are different powers. Okay, and what that power is you drop the power from 4, drop it to 3, and so you have x cubed plus, and then you kind of go up by powers of 3, and you drop powers of the exponent. So I have then 3x squared plus 9x plus 27. You're going up by powers of 3 as you're going down with powers of the variable. Now, in front of my students, you're like, what in the world is that? Or you had forgotten that pattern. You can always derive it by just dividing it. Okay, and that's what I'm going to do right now. So I'm going to divide this, and I'm going to use synthetic division because I have it. I'm dividing by x plus or minus some number. Okay, again, I changed this sign once, so after this I can just add. And I'll put this polynomial over here to divide by it. I'll put in lots of zeros for missing terms. So that's my x to the 4th term, x cubed term, x squared term, x term, and then my constant term is 3 to the 4th power. Just double checking myself, which is 81. Okay, so I'll do synthetic division. Bring the 1 down. I'll kind of do this kind of quickly. 3 times 1 is 3. I add down. 3 times 3 is 9. I add down. 3 times 9 is 27. I add down. 3 times 27, oops, I'm sorry, it's minus 81, is a positive 81, which adds to be 0. Okay, notice it divides evenly. Okay, and what I'm left with, this is the constant term, linear term, quadratic term, cubic term. So I get x cubed plus 3x squared plus 9x plus 27. Okay, whether you memorize the pattern or you just can divide it, either way is fine. Okay? Number 9, determine the quotient using polynomial long division. So if I use long division, here we go. So I have x squared minus x plus 2. And I have 4x to the 4th power. Now, I like putting in zeros for the missing terms. You don't have to, but it gives me a column to put things. So I'll put plus 0x squared, x cubed, sorry, plus the 3x squared plus 0x plus 4. Okay, here we go. X squared times what is x to the 4th? Well, the answer is x squared. And then I'll multiply this times each of these terms. X squared times x squared is x to the 4th. Woo, x to the 4th. X squared times negative x is negative x cubed. And negative 2 times, sorry, 2, woo, x squared times 2 is plus 2x squared. Right? All right. Now I will change all the signs and add. That's how I teach it. I think each teacher teaches it a little differently. I think Ms. Stanoff just like subtracts it, but I like to change all the signs and add. So the x to the 4th term cancels. X to the cubed term is just x cubed. 3x squared minus 2x squared is plus x squared. Okay, and I will bring down this plus 0x. All right, now what times x squared equals x cubed. Well, it's plus x. So x times x squared is x cubed. X times negative x is negative x squared. X times 2 is plus 2x. And then I will change all the signs and add. So the x cubes cancel, x squares, I get 2x squared, and I have a minus 2x, and I'll bring down my 4. All right, next, x squared times what is 2x squared? The answer is plus 2. And 2 times x squared is 2x squared. 2 times negative x is negative 2x. 2 times 2 is plus 4. I like that's the exact same all the way down. I will change all the signs and add, and that cancels, and that cancels, and that cancels, and I have 0, which means it divides evenly. Okay, the quotient is this thing up here, which is x squared plus x plus 2. All right, that's it. Be very careful with negative signs. That's why I like to change a sign and circle it. I found by doing that, I make fewer mistakes myself. Okay, a right triangle has leg lengths of x plus 1, 3x minus 2, with hypotenuse of 2x plus 1. Okay, well here I have my right triangle, and I have legs, that's the two sides, x plus 1 and 3x minus 2, and the hypotenuse is 2x plus 1. Well, when I think about side lengths of right triangles, I think of the Pythagorean theorem, which is a squared plus b squared equals c squared, okay, where c is the hypotenuse. So this one right here, this is going to be c. The other two, a and b, don't really matter so much, so I'll plug those in. X plus 1 squared plus 3x minus 2 squared equals 2x plus 1 squared. Okay. Now, at this point, let me point out a common error that I've seen with my students, at least. I'm not sure the other teachers are seeing this too, but the next step is not x squared plus 1. Okay? You can't get it by squaring both of these terms. That's incorrect. Okay? X squared means times itself. So you must do x plus 1, x plus 1, plus 3x minus 2 times 3x minus 2. And we have 2x plus 1 and 2x plus 1. Okay, now I got a lot of distributing ahead of me. So x times x is x squared. X times 1 is plus x. 1 times x is plus x. 1 times 1 is plus 1. Plus 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3x is minus another 6x. And negative 2 times negative 2 is plus 4. Equals 2x times 2x is 4x squared. 2x times 1 is plus 2x. 1 times 2 is plus 2x. 1 times 1 is plus 1. Whew, I barely made it on the end of that page. All right, combine like terms, x squared plus 9x, yeah, that's right, is 10x squared. The like terms, x plus x is 2x, minus 6 is negative 4x, minus 6x is negative 10x. That seems right. And 1 plus 4 is plus 5. Equals. I have 4x squared plus 4x plus 1. Now, I will give you a hint. The one on the review packet, you have the same x squared terms, and so as you subtract those together, you have a linear term left. This one is not. This is a quadratic, and so I'm going to try to solve this. Hopefully, it factors nicely. I like to have positive leading coefficients, so I'm going to subtract everything to go on the left side. Now I can, because I'm solving an equation, I can divide every term by 2 to make it a little easier for me. If I do that, I get 3x squared minus 7x plus 2 equals 0. And I want to factor this, but this leading coefficient is not 1. So I have to use like the full the full A&M method with the skeleton. Now I'll give you a hint again. The one on the packet don't have to factor with the skeleton with the A&M, but this one I'll go ahead and finish this problem. The ATM method. I'm going to add to be -7, multiply to be 3 times 2, which is 6, and that is -6 and -1. Okay. Now with the skeleton, I'm going to have 3x over 3. And the numbers I have is -6 and -1. There's always one that has a GCF. That's this first one. I'm going to kind of add a space. I'm going to go this way. And I have, let me just rewrite this so it's kind of easier to see. 3x minus 6, 3x minus 1 over 3. I'll pull out a -3 out of this first binomial. And I have x minus 2 and 3x minus 1 divided by 3. Now this 3 and this 3 cancel. Ba-bam, ba-bam. So you can factor things out in front or things out of, anyway, but not things inside of binomials. And I'm left with, again, don't forget that it's equals 0. 0 is equal to x minus 2 and 3x minus 1. If I put each of these factors equal to 0 and use the zero product property, then I have x is equal to 2 and x is equal to, now this one, if you add 1 and divide by 3, you get 1/3. So the question was, what are the actual numeric side lengths? Let me plug that back in. We have 2 options. I think the one they meant to was the whole number one, but 2 plus 1 is 3. Oops. Is 3. 3 times 2 is 6, minus 2 is 4. And then 2 times 2 is 4 plus 1 is 5. Okay, but the one that also works, I'm going to put that down there just for fun, is 1/3. So 1/3 plus 1 is 4/3. And let's see here, 1/3 times 3 is 1, minus 2 is -1. And so this tells me that this one is, even though we've not talked about it like this, it's an extraneous solution because I can't have lengths that are negative. So the answers are 3, 4, 5, which 3 squared plus 4 squared is 5 squared. Woo! Okay, so I think this one was a little harder than the one that's in the packet that you're doing, but the same principles apply, that you still plug in the Pythagorean theorem, you still simplify. That becomes a linear that you can then solve pretty simply. All right. Number 11, the expression 2 minus x plus 2 over x minus 2 is equivalent to which of these? Now, I'm going to use the fact that it's multiple choice to help me. This is 1 plus or minus something. So I want to pull a 1 out of here somehow, and I'll think about 2 being 1 plus 1 minus x plus 2 over x minus 2. And then I will take this 1 right here, this 1, and make that into a fraction with the same denominator as this right here. So I'll make this as x minus 2 over x minus 2. Minus, I still have my x plus 2 over x minus 2. And then I want to combine these next two fractions. I still have my 1. And I think the way that I've been thinking it through has to do with x minus x is 0. That cancels. And then if I have, I can't really make that big enough. And then -2 minus x minus 2. So -2 minus 2 is a minus 4 but I still have my denominator of x minus 2. So then I would have x minus 4 over x minus 2. Okay? If you go about this with distributing this negative, make sure you do it carefully. So you may need to distribute, if you kind of want to make a one fraction, make sure you distribute the negative correctly, because that's the most common place to make a mistake. Okay? I'm going to scroll up because I'm next going to do long division, and I want some more space for that. Okay, number 12, the expression 4x squared minus 3 divided by 2x minus 1 is equivalent to which of these? Now, again, I do this a little different than some of the other teachers, perhaps. I would see, well, it's division, so I'm just going to do some long division. Okay, and I will do it that way. But I know some of the other teachers have taught kind of looking at patterns that I've not talked about. And we know that because I know that 2x minus 1 times 2x plus 1 is equal to, it's a difference of squares kind of thing. So we get 4x squared minus 1. So I can kind of isolate that out of the top. That's the patterns that some of the other teachers have taught. 4x squared minus 1 minus 2 more, so I still have my minus 3. And I can look at that being divided by 2x minus 1. Now if I pull out and separate that into two separate fractions, as 4x squared minus 1 over 2x minus 1 minus 2 over 2x minus 1. I can rewrite this part. Let me just rewrite it again down below. I'll rewrite this part right here using this version, 2x minus 1, 2x plus 1, divided by 2x minus 1, minus 2 over 2x minus 1, and this will cancel with this, and I'm left with 2x plus 1 minus 2 over 2x minus 1, which would be, yeah, that one. Okay, so you can approach it that way. Now, before my students, and that's like, whoa, what in the world? You can get this using long division. Okay, so let me show you long division. Now, this is not in the form that I can use synthetic division, so I have to use long division. So I have 2x minus 1, long division of 4x squared. I have no x term, so 0x with a space for it, minus 3. I'm going to go kind of fast. 2x times what is 4x squared? It is 2x. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. I'm going to change all the signs and add, and I get 2x. I bring down my minus 3. Now 2x times what is 2x? The answer is plus 1. 1 times 2x is 2x. 1 times negative 1 is negative 1. I change both the signs and add. The 2x's cancel, but I have negative 3 plus 1 is negative 2. And then I get from that negative 2, as the remainder, I have minus 2 over the divisor, which is 2x minus 2x, 2x minus 1. In which case I get the same answer. Okay? All right, 13. I believe this was a typo. It's minor. I don't know if you would have noticed, but that's x. Given x is greater than 0, then what is the expression equivalent to? Now, this was changed in this version not to have multiple choice, so let's just kind of figure it out. Now, this I will think about with fractional exponents. That's how it was in the review packet. So a square root is the same as a power of negative of 1/2 times, and this 8x squared y cubed, the power of 1/3. So fractional exponents. Okay. Let's see here. 2. The square root of 2, or 2 to the 1/2, is just 2 to the 1/2, or square root. Okay? X cubed to the 1/2, I'm going to multiply that together. That's how you do with laws of exponents. An exponent to an exponent you'd multiply. So I have x to the 3/2 power. And y, you know what, I think I'm going to edit this too. Okay, number 13, given, I believe it's x greater than 0, not y. Anyway, I'm not sure if you would have noticed. But I want to simplify this expression somehow. Okay, now I have 2, I have the square root. And I'm going to think about the square root as having fractional exponents, because that's how it was in the review packet, the other one that had multiple choice. Okay, so I'll think about not the square root of 2, although it is. I'll think about 2 to the power of 1/2, because 1/2, the power of 1/2 is the same as a square root. Okay, the x, however, has a power of 3 and a root of 2, and so the power is 3/2. It's always power over root. Okay, the square root of y squared is y times. Now, the cube root of 8 is 2, because 2 times 2 is 4, 4 times 2 is 8. Okay, the x squared, the cube root of x squared, again, is you have power over root. So I have 2, power of 2 over root of 3. And for y, I have the cube root of y cubed, and that means y is the thing that if I cube it, I get y cubed. Okay, so now combine like terms. It's not exactly combine like terms, but it feels like that. So I'm combining the same numbers together, the same bases together. 2, now the rules of exponents are when you have the same base, you add the exponents when you're multiplying. So let me go over here, and I have 1/2 plus, this is a power of 1, plus 1. Now to add these fractions, I need a common denominator. And so 1/2 plus 2/2 is 3/2. So we get 2 to the 3/2 power. X, let's see here, what happens with x? Well, again, I'm adding exponents. So I have 3/2 plus 2/3. I need a common denominator, which is the denominator of 6. So multiply this by 3 over 3, and this by 2 over 2. And I get, let's see here, 9 over 6 plus 4 over 6. And I get 13 over 6. So x to the, 13/6 power. And y to the first times y to the first is, you add the exponents, 1 plus 1 is 2. Okay? All right. Number 14, the expression 3 minus the quantity 2x minus 3i squared is equivalent to what? Now again, this is multiple choice in your packet, but we're going to actually just simplify it. So 3 minus, now squared means times itself. So I have 2x minus 3i and 2x minus 3i. And I'm going to distribute. So 2x times 2x, only 3 minus parenthesis. Don't forget that parenthesis, and the negative sign will be the common place that you'll make a mistake in this one. 2x times 2x is 4x squared. 2x times negative 3i is, let's see here, negative 6ix. I think xi is using the answer key for some reason. Xi, even though I usually put the variable at the end. Negative 3i times 2x is negative 6xi. And then negative 3i times negative 3i is positive 9i squared, close parenthesis. All right, Let's combine like terms and do some things like that. So let's see here. I have 3 minus, let's combine like terms and then I'll take care of the negative. 4x squared, negative 6xi minus 6xi is negative 12xi. Now the negative I squared is negative 1. Okay, so plus 9i squared is the same as minus 9. Okay, now we'll deal with that negative sign. So 3 minus 4x squared plus 12xi plus 9. If I combine the 3 and the 9 together, then I get negative 4x squared plus 12xi plus 12. And that's it. All right. Number 15. The completely factored form of this polynomial is what? Now, in this one, I taught my students that you can factor the one that you have by grouping. This one, unfortunately, the way it was written, you can't do by grouping. So I'm going to do this one kind of thinking through what it means to have a factor. Okay, I noticed that I need it to be completely factored, so it's not the first one. Okay, I then noticed that these are all the same, and that these are all the same, and so I'm really looking at like x plus 1 or x plus 3. It's one of those two. So I'm going to use synthetic division to see if 3 or negative 3, and if 1 or positive 1 is a factor. Okay, so I'll do synthetic division because it's x plus or minus a number, and I'll start with the negative 3, testing to see if this is a factor or not. We pull off the coefficients, 1, negative 7, no, I'm missing x cubed terms, so 0, negative 7, 8, oh, just kidding. The order is all funky. Okay, let me reorder this. X to the 4th minus 2x cubed minus 7x squared plus 8x plus 12. If I now use synthetic division, I have negative 3, and I have 1, negative 2, negative 7, 8, and 12. Okay, bring the 1 down. Negative 1 times 1 is negative 3. If I add down, then I get negative 5. Negative 3 times negative 5 is positive 15. If I add these, then I get 8. Negative 3 times 8 is 24, negative 24. Negative 8 minus 24 is negative 16. And negative 3 times negative 16 is 48. Is that right? Yeah? And I get 60. It's not 0. Okay? Which makes me think that this is not a factor. This is not a factor. Let me just check myself and make sure that I'm not making a big mistake. Let me see if this one is going to work. I'll switch colors just for fun. Let me see if this one works. So I'll make that a positive 3. Let me erase all of these and see if I've just made a mistake somewhere. Okay, so I'm now using positive 3. 3 times 1 is 3. Negative 2 plus 3 is 1. 3 times 1 is 3. Negative 7 plus 3 is negative 4. 3 times negative 4 is negative 12. 8 minus 12 is negative 4. 3 times negative 4 is negative 12, which is 0, which is a factor. So this is a factor. The other ones aren't, and so this must be the answer. Okay, you can approach it that way. Other ways to approach it, you can just graph this and look at where the zeros are. So the zeros will be at negative 2 and positive 2 and positive 3 and negative 1. And looking at those zeros and saying, well, it's got to factor into that as well. You can also use synthetic division and then, then divide by other things and then factor. But I think this is one way to do it. Again, the one in the packet, you can factor by grouping, or you can do it this way as well. Okay. Number 16, given that g of x is 2x to the fourth minus 3x plus 4, and h of x is x plus 1, determine g of x over h of x in the form q of x plus r of x over b of x. Okay, so what do you do? Well, I'm given g of x and h of x, and I want to determine this, which means I'm dividing that that function by that function. Okay, so just kind of reading and figuring out what to do is a challenging part, but this I'm just going to do some division. Okay, I'm dividing by something in the form of x plus or minus a number, so I'm going to use synthetic division. I will change this sign once, so I can add from then on, and I'll pull off the coefficients. I have lots of missing terms. I have 2, and then I have no x cubed term. I have no x squared term. I have -3, and I have +4. Okay, I'm going to bring down the 2. -1 times 2 is -2. 0 minus 2 is -2. -1 times -2 is 2. If I add 0 plus 2 is 2. -1 times -2 is -2. Yeah. Plus -2 is -5. And -1 times -5 is +5. And 4 plus 5 is 9. So this last number here is the remainder. And so that remainder is 9 over what I divided by, x plus 1. And this is my constant term, linear term, quadratic term, cubic term. So what I get is I get 2x cubed minus 2x squared plus 2x minus 5. And then I get plus, because it's positive 9. Okay? Now the question being asked next is h of x a factor of g of x? And the answer is no, because the remainder is not 0. Okay, this remainder is 9, which means if I divide it, I still have some left over, and so it's not a factor. Next, we'll look at number 17. Solve the following by factoring. Okay, so when we factor, we're going to be using eventually the zero product property to solve it, and so I need to get one side equal to 0. I like my leading coefficient, my leading term, to be positive, and so I'll move everything on the right to the left side. So I'll subtract 2x from both sides, and I will add 1 to both sides. I'm putting this in the normal order with descending powers. I have 2x cubed minus x squared minus 2x plus 1. Okay. Now, if I'm solving this by factoring, then I'm going to hope this can factor by grouping, because that's how I group. That's how I factor cubics. Okay, so I will try looking at this group and this group, and looking for a common binomial that will factor as a result. So in these two terms, the GCF is x squared, and what I'm left with is 2x minus 1. Okay, now in the next pair, I want to have a 2x minus 1 left if that's possible. Okay, I'm going to factor out a minus 1, and then I'll have left, let's see here, -1 times what is -2x? The answer is 2x. And the next one is a little tricky. -1 times what is +1? Well, a negative times a negative is a positive. And I do get my 2x minus 1 that I wanted. Okay. Now the way I write the next step is, in my mind, I'm pulling out the 2x minus 1, this one, and this one out to the front. And I have 2x minus 1. And what I'm left with is x squared minus 1. Now I will also notice that x squared minus 1 is the difference of squares. So I can factor that one more time. So I have 2x minus 1, and then I have x plus 1, x minus 1. Okay, and now I use the zero product property and put each pair of binomials, each factor equal to 0. Okay, I'll just go over here From this one, if I put that equal to 0, I would add 1 to both sides and then divide by 2. And I would have x equals 1/2. For this one, I would put that equal to 0, and I'd subtract 1 from both sides, and so I'd get x equals -1. For this last one, I would add 1 to both sides, and I would get 1 as my answer. So the solutions to this is x equals 1/2, -1, and +1. Next, number 18. When factoring to reveal the roots of the equation x cubed minus 3x squared minus 4x plus 12 equals 0, which equations can be used? Okay, so I want to factor this, and it looks like factor by grouping, right? So I have this and I have this, like I have similar things, and so I want to say again, I'll just try factoring by grouping and seeing what happens. So I'm looking, it's in the right order, and I'm going to factor out of these two and these two. Okay, the first two has x squared in common, and I'm left with x minus 3. Okay, and then out of the next two, I'm going to factor out a -4, and I'm left with x, let's see here, -4 times what is positive 12? A negative times a negative is a positive, so that's -3. Okay, which looks like this one equals 0, sorry, equals 0. This one is good. Okay, that one's good. Okay, and then I'm going to pull out the x, let's see here, I could pull the x minus 3 as well. The best way to go about this. Can I factor out? Can I switch the order? I can switch the order. Okay, so let me look at this way. So instead of going that route, this might be kind of strange, but I'm seeing which of these I can get to. So let me go back to the very beginning. Let me switch around the order. If I look at x squared minus 4x minus 3x squared plus 12 equals 0 by switching the order of these two. And then I try factor by grouping again. I'm looking at these two and these two. I get the first two has GCF of x, and I'm left with x squared minus 4. Out of the next two, I'm factoring out a -3, and I'm left with -3 times what is -3x squared? It's x squared. -3 times what is positive 12? Again, it's a -4. And it looks like I have this one. Those last two look good. Looking at the very first one, if I kept going and finished this factoring, then I would get, let's see here, bring the x squared minus 4 to the front, x squared minus 4 to the front, and I'm left with x minus 3 equals 0. I lost my equals 0 over there. And what I notice is that this sign right here is not right. Okay, and so it looks like the answer is 2 and 3 only. So I'd say 3 is the answer to that one. In number 19, we will algebraically determine the roots in simplest a plus bi form to the equation below. So a plus bi is in complex, it's a complex number, which gives me a hint that I'm going to be using the quadratic formula and that I will get some complex solutions as a result of that. So before I can use the quadratic formula, I must get one side equal to 0. Now I like my leading term, my leading coefficient to be positive, and so I'll move the things on the right to the things on the left. So I will do opposites. I will add 2x to both sides, and I will add 5 to both sides, and I get x squared minus 6x plus 15 equals 0. Okay, so next I will use the quadratic formula, which we will not be giving to you on the exam. Okay, so you should memorize it. Okay, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, where a, b, and c are the coefficients. So in this case, a is 1, b is -6, and c is positive 15. Okay, so plugging those in, x equals a -6. So -6 is a positive 6 plus or minus the square root of -6 squared minus 4ac A, and A is 1, and C is 15, all over 2 times 1. So simplifying a bit, I get x equals 6 plus or minus the square root. Let's see here, negative 6 squared is 36, minus 4 times 1 is 4. 4 times 15 is, let's see here, 60 over 2. Okay, so going one step further, 36 minus 60 is negative 24 over 2. So this negative right here is where is the reason why I'm going to get some complex solutions. Okay, so let me simplify the square root of negative 24. Let me just look at 24. So 24, what's the lowest prime that divides 24? The answer is 2. And 2 goes into 24 12 times. And the lowest prime that divides 12 is 2. And that goes into it 6 times. The lowest prime that divides 6 is again 2, and it goes into it 3 times. And then 3 is the lowest prime that goes into 3, and it goes 1 time. And I see that I have a pair of 2's, which gives me a perfect square of 4, because 4 goes into 24. Okay, that pair of 2's give me a perfect square of 4, and the square root of 4 is 2. The square root of what's left, which is 2 times 3, and 2 times 3 is 6. So the square root of 24, positive 24, is 2 root 6. Okay. Now the square root of negative 1 is I, and so the square root of negative 24 is 2 root 6 I. Okay, so plugging that in, I get x equals 6 plus or minus 2 root 6 I over 2. And now I want to cancel off a 2 that's in every single term. Okay, I cannot just cancel off, and I'm also going to cancel out of whole numbers. Okay, you can't cross out of things, whole numbers and square roots. And I also can't cross out just some of the terms. It's either everything or nothing. So this is 2's in here. A 2 goes into this one time, a 2 goes into this. So that's every single term. I've taken a multiple 2 out, and I'm left with 3 plus or minus the square root of 6i. Now those are two answers, both 3 plus root 6i and 3 minus root 6i. Number 20. Evan graphed a cubic function f of x equals ax cubed plus bx squared plus cx plus d, that's the general form, and determined the roots of f of x to be plus or minus 1 and negative 2. What is the value of b if a is equal to 1? Okay, so we are going to just reconstruct this from the roots. So if these are my roots, I have plus or minus 1. That means if I factor it, I would get x plus 1 and x minus 1. Would give me roots of plus or minus 1. A root of negative 2 means I also have x plus 2. Okay, let me check my a is going to be equal to 2. If I multiply the leading terms from each of these, I get x cubed, which would be true if a is equal to 1. So that checks. I don't need to multiply by any other number. Okay, so I simply need to multiply this out and see what I get for b. Now I'll go very slowly. I will first only multiply these first two binomials together and then deal with the last one later. Okay, I've seen lots of my students make mistakes of doing this kind of stuff, which is wrong. Okay, it's not multiplying times all of them, it's only multiplying 2 at a time. Okay, so I'll only do just these two first. So x times x is x squared. X times negative 1 is negative x. 1 times x is plus x. And 1 times negative 1 is negative 1. Okay? And I still have my x plus 2. This simplifies these two terms. Let me change colors here. These two terms right here cancel each other out. Bam, bam. And I have x squared minus 1 and x plus 2. Now I'm going to keep writing going down, even though I'm kind of going to go out of the box, but I hope that's okay. And now I'll go again, and I'll distribute this into these two terms, and this into these two. So x squared times x is x cubed, and x squared times 2 is plus 2x. Negative 1 times x is minus x, and negative 1 times 2 is, let's see here, minus 2. Okay, and I made a mistake somewhere. X squared, this one is squared. Yeah, that's it. So that looking at this, I can tell that b right here is the coefficient of x squared, which is positive 2, which is positive 2. Okay, not too bad. Let's scroll up. So solve each radical equation and check your solutions, checking for extraneous solutions. Okay, so the way we solve radical equations is we solve for a square root, and then we square both sides. Okay, and 21 is done for us already. That's very nice of them. So I'll just simply square both sides. If I do that, the square root of 4 minus 3x is positive 4 minus 3x equals x squared. Now this is a quadratic equation, so I will solve one side equal to 0 and try to factor if I can. And I'll move everything on the right side because I want a positive leading term. So I'll add 3x and minus 4 from both sides. And I have 0 is equal to, I want to make sure I have space for number 22. I have 0 is equal to x squared plus 3x minus 4. And let's see, does that factor? It does. It factors using this, what I call the simplified ATM method. Two numbers that multiply to be negative 4 and add to be positive 3 is a positive 4 and a negative 1. Okay, and so solving each of those using the zero product property, I have x equals negative 4 and x equals positive 1. I now need to check both of them to make sure that I don't have any extraneous solutions. So quickly plugging them back in, I have the square root of 4 minus 3 times negative 4. Does that equal, question mark, negative 4? Well, solving things inside the square root, I have 4 plus 12. Does that equal negative 4? I have the square root of 16, which is equal to 4. I know that. That does not equal negative 4. This is an extraneous solution. And let me check the positive one. Okay, because it's possible that one works and that both don't work. So I should check both of them. I have the square root of, I'm getting low on space, 4 minus 3 times 1. And does that equal 1? I had the square root of 4 minus 3. And does that equal 1? That's square root of 1, which does equal 1. So this one's good. Okay, let me do the next one. This one, I've solved for a radical. In fact, I've solved for both radicals. That's nice. If I square both sides, then the radicals go away, and I have 11x plus 41 is equal to 15x minus 7. I want to solve this linear, so I'll get my x's to one side and my numbers on the other. I like positive leading terms, so I'll subtract the 11x, and I'll add 7 to both sides. And I have on this side, I have 48 is equal to 15 minus 11 is 4x. Let me switch colors. If I divide both sides by 4, then x is 12. Oh, that's it. Okay, I still need to check it though. So if I check it, I have the square root of 11 times 12 plus 41. And is that equal to the square root of 15 times 12 minus 7? Okay, 11 times 12, I don't know what that is. Plus 41, I'll just do all at the same time. I have the square root of 173. And is that equal to 15 times 12 minus 7? I get 173. So that works. This is the solution. Okay, this last one, again, I've already solved for a square root. And so I will square both sides. Okay, very careful that x minus 4 squared is x minus 4 times x minus 4. And that's going to be equal to negative 14x plus 7. I will distribute, and x times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is, again, another negative 4x. And negative 4 times negative 4 is a positive 16. And that's equal to negative 14x plus 7. Okay, so I get x squared minus 8x plus 16, and that's equal to negative 14x plus 7. Okay, and let's see here. I want to get everything. This is a quadratic. I'll get everything to the left so that I have a positive leading term. Plus 14x plus 14x minus 7 minus 7, and I have x squared. Negative 8 plus 14 is plus 6x. 16 minus 7 is plus 9 equals 0. Okay, now I can factor this by two numbers that will multiply to be 9 and add to be 6. That's positive 3 and positive 3. And I have x equals negative 3, and that's the only solution. It's a has multiplicity of 2, but I still need to plug that in to see if that one works. So hopefully it does. I have negative 3 minus 4 equals the square root of negative 14 times negative 3 plus 7. On this side I have negative 7, which by the way is a hint that it's not going to work because I can't have a negative come out of a square root. But I'll keep going. Square root of negative 14 times 3, I think is 42. 42 plus 7 is 49. Now, the square root of 49 is positive 7, not negative 7. This one does not work. It's extraneous, and so there's no solution to this equation. Okay? So again, you just solve for a square root, get that by itself, and then you square both sides, and then use some algebra and check at the end. Okay. Write the following rational expressions in their lowest terms and box your final answer. So in this, you want to factor the denominator. Okay, that's the first step to do. And then you're looking for common denominators. Okay, so in this one, I'll first factor the denominators. I have 7x minus 7, minus 9. Okay, in the bottom here, I have a GCF of 3x, and I'm left with x minus 1. Minus 2x minus 1. Now I'll give you a teacher hint, is that usually you'll have the same thing happening. So I have this term and this term here. If that doesn't happen, just double check your factoring. This is a terrible place to make a mistake because then everything else is based on that. And so double check that. But I do have it the same. And so I want a GCF. So I ask myself, what does the other denominator have that this one doesn't? And that is nothing. It has everything. And what does this one have that this one doesn't? The answer is a 3x. So to keep it the same, I multiply top and bottom by 3x. And that's multiplying by 1. So it won't change the value of that second fraction, but I will now have a common denominator. So rewriting this, I have 7x minus 9 over 3x times x minus 1. And I have minus 2 times 3x is 6x over 3x times x minus 1. Okay, so now I'm going to kind of combine it all into one big fraction. So I'm looking kind of, the bottom is just my 3x times x minus 1. The top has this, where 7x minus 6x is just x, and the top is minus 9. Now, could I factor anything and cancel anything off? The answer is no, and so this right here is my answer. Okay, number 25 is division. And the first step is to factor everything. Okay, and at first glance, I noticed that this right here will require the ATM with a skeleton. So I'm going to start there because that's kind of a lot of work and do that separately. And then I'll kind of address looking at how to divide it. Okay, so I'm looking, this is the ATM. I'm writing kind of small because this will be kind of long. I want them to add to be 3 and multiply to be 2 times negative 2, which is negative 4. And the two numbers that add to be 3 and multiply to be negative 4 are the numbers, let's see here, positive 4 and negative 1. Okay, now the skeleton is ax, which is 2x and 2x over 2. And then my numbers again are plus 4 and minus 1. There we go. Now this first binomial, the 2x plus 4, has a GCF of 2. I can factor that out. And I have x plus 2 times 2x minus 1 over 2. And this 2 cancel. Bam, bam. So I have this right here. This is the factored form of this. So let me rewrite this using factor. I think I can do everything else kind of on the spot, but that one I want to do separately. So that one is x plus 2 times 2x minus 1. This right here, that's a simplified ATM. Two numbers that multiply to be negative 5 and add to be negative 4 is negative 5 and positive 1. Yeah? Okay. Divided by, I'm looking at this one now, this is the difference of squares. I have the square root of 4x squared is 2x and 2x. And then the square root of 1 is 1. So I have plus and minus. And then last but not least, this one. I have, this is simplified ATM. And I have two numbers that multiply to be 2 and add to be 3 is plus 2 and plus 1. Okay, so next, if we think about what does division mean, well, how do you do division with fractions? It's where you multiply by the reciprocal, so you flip over the second fraction. This fraction right here, I'll flip it over and change it to multiply. So I'll rewrite this. I have x plus 2 and 2x minus 1 over x minus 5, x plus 1. I will flip over this fraction, x plus 2, x plus 1. Whoops, my hand slipped. Divided by 2x plus 1 and 2x minus 1. And now's my favorite part of this entire problem, is where you start canceling things off. Things are in the top and the bottom. And I'll kind of change colors to make it easier for you to see. Let's see here, this and this. And that looks to be about it. I know that you see this right here. That's blue's fine. You see this right here and this are the same, and so you want to cancel it, but those are both in the numerator, so don't do it. Okay, so what you get is, come on, you get x plus 2 squared divided by x minus 5 and 2x plus 1. Woo! Okay, the most common mistakes I see with that one is factoring correctly. So be very careful about factoring those. Take that slowly. Okay, number 26, what is, in fact, I'm probably just going to erase this and scroll up so I can have more space. 26, what is the solution set of, whoops, not that, of this equation? So I'm solving an equation, and again, the first thing I do is factor all the denominators. Okay, let me go over here. 4 times x minus 1, that can't be factored, equals 4 divided by, now this has a GCF of x, so I factor that out, and I have x minus 1 plus 3 over x. It's super, super important to factor that very first step, so that when you're looking for your least common denominator, that you don't have more than you need. I found many students don't do that first step and they have a bigger denominator than they need, and it gets really hard later on in the problem. So do that first. Okay, now looking at it, what does the other two denominators have that this one doesn't? The answer is an x. So I'll multiply top and bottom here by x. Okay, what do the other two have that this one doesn't? The answer is nothing. It has everything, and that's the important piece, so it doesn't get more complicated than it needs to be. What do the other two have that this one doesn't? And the answer is an x minus 1. So multiply top and bottom here by x minus 1, which is equal to 1. And so it's not changing the value of the fraction. Okay, let me rewrite this with those things multiplied in. So I have 4x divided by x times x minus 1 equals 4 over x times x minus 1 plus, let's see, I'm going to distribute this while I'm at it, 3x minus 3 over x times x minus 1. Okay, now at this point, I think each teacher thinks about this a little bit differently. The way I think about it is I just pull off the numerators. I know the other teachers think about multiplying everything by that least common denominator. Either way you approach it, you still get to the step of 4x is equal to 4 plus 3x minus 3. Okay? And now I'm not being very careful because sometimes if there's a negative here, that's a very common question being asked, is that this is a negative. If that's true, be very careful about distributing that negative, but this one's positive, and so that's not an issue with this problem. Okay, so this is linear, and I will get my x's to one side and my numbers on the other, and I will get my x's on the left, so I'll subtract 3x from both sides, and I'll just keep going down. So x is equal to 4 minus 3 is 1. Okay, now I'm going to check to see if that might give me division by 0 at any point in the problem. And looking back here, I see, I'm going to change my highlighter. I see that this right here would give me division by 0 here, here, and here, right? So this is an extraneous solution, and I have no solution. Okay, and this right here is braces with nothing inside, so there's no solution, number 4. Okay. Number 27, I'm looking at this polynomial for the next 3 problems. Okay, this one right here. Given that p of 1 is 0, what must be a factor of p of x? And the answer is x minus 1 must be a factor of p of x. Okay, 28, given that x plus 3 is also a factor of p of x, list all the zeros of p of x. Remember that p of x is a 4th degree polynomial. Okay, so what I'm going to do is start using synthetic division to make this simpler. Okay, and so first dividing by x minus 1, I'll switch that sign once. So from now on I can add. Pulling off the coefficients, I have 1, 6, 9, -4, and -12. Okay, so I'll do synthetic division. 1 times 1 is 1, 6 plus 1 is 7, 1 times 7 is 7, 9 plus 7 is 16, 1 times 16 is 16, negative 4 plus 16 is positive 12, 1 times 12 is 12, and -12 plus 12 is 0. Okay, so again, this is a 3rd degree polynomial left, this 1, 7, 16, 12. I'm not going to write that as a polynomial because what I want to do is just turn around and do synthetic division again. Okay, and I'm going to take a shortcut as far as notation, which is commonly done if you're doing this a lot, and just go like this. I'm now just going to do it again with these new coefficients. Okay, I've been told that x minus 3 is also a factor, and so I will divide by that, which again I changed the sign once, so from now on I can add. And I will bring this down. -3 times 1 is -3. 7 times -3 is 4. -3 times 4 is -12. 16 minus 12 is 4. -3 times 4 is -12, and it adds to be 0. Okay, so again, this is my remainder, which means it is a factor. Okay, and what I'm left with here, this is constant linear quadratic. I have a quadratic equation left, which is x squared plus 4x plus 4. Okay, which is factorable. So I can factor this. Two numbers that multiply to be 4 and add to be 4 is positive 2 and positive 2. Okay, so the factors of this polynomial is starting with x minus 1. Oh, so all the zeros. My bad. Okay, all the zeros. All the zeros are 1. This one right here gives me negative 3. This one gives me negative 2, and this can be another negative 2. Notice this is a multiplicity of 2. Okay, which will affect the graph. Okay, now I'm going to sketch that graph, and I'm going to scroll up. So I'm going to lose this, but I'm actually going to keep my zeros. So to kind of erase everything else. Okay, so sketch a graph. That's nice. I still have that down there. Okay, so sketch a graph of p of x on the axis below. Guess what? I can't see the x-intercept. So the y. Okay, the y-intercept is negative 12. Or 0, negative 12, I should probably write. That's all that I need. It's a fourth degree. The leading term is x to the fourth. That's all the pieces I need. Okay, let me try again. Okay. So the first thing I look at are the zeros. So the zeros down here, I have positive 1, I have negative 3, and I have negative 2. Okay, so let me kind of label this a little bit. So I have 1, 2, well, I'll label this as 1, negative 2, and negative 3. Okay, the next thing I look at is the y-intercept is at negative 12. So I can just put a dot and say it's negative 12. Okay, and the last thing I look at is this. So this leading term, x to the fourth, tells me that the leading term is positive and the power is even. Okay, and the end behavior for a leading coefficient, if it's positive, and an even term is up, up. So I will somehow end this up, up. Okay, 3 has a multiplicity of, that's odd, 1, so I'll go through there. 2 is even, so I'll bounce or touch, negative 2. I will go through 12 somehow. It probably, I'm just guessing here. I'm just guessing it, the graph. It's probably going to go down and then kind of come back up here somewhere. That's my guess. That would be the smoothest graph. Okay. Now, I don't know what it looks like. You will study this more in future classes and have more about the curvature of these. But as far as now, if you can nail the intercepts and the multiplicities and the x and y intercepts, then that's sufficient. So there's my sketch. Now, here's a teacher hint, is you are given a graphing calculator. You can graph it and look at that and compare that with what you have. It's a good way to check, but we'll be looking for all the details of the intercepts and the end behavior and stuff. So you should be able to kind of do this, but you can check yourself by graphing it on the calculator. Okay, number 30. Solve each system of equations algebraically. Show all work, justify your answer, box your final answer. You should check your solution or solutions in both equations. Okay, so looking at this, I'm going to just plug using substitution. Now, you can't really use elimination in these. You have to use substitution. So I'm going to plug this right here, which is equal to y, in for this y. And I get x plus this big equation, x squared minus 2x plus 4 equals 4. Okay, and then I solve that. This is a quadratic. I will get one side equal to 0. I'll subtract 4 from both sides. And I'll rewrite this in a better order. So I have x squared. X minus 2x is minus x. And then that's 0 equals 0. Okay, now I can factor, and this has a GCF of x. So I have x, and I have x minus 1 equals 0. Okay, now using the zero product property, I have x equals 0, and x minus 1, well, I think we're okay with just writing x equals positive 1. Okay, so I want to find the corresponding y values. So I'm going to use the simpler equation, this one right here, that x plus y equal 4. So what, 0 plus what equals 4? The answer is y is equal to 4. And 1 plus what equals 4? The answer is 3. So I have my solutions of 0, 4, and 1, 3. Okay, I know those work in my top equation because I plugged it in there, but checking the bottom equation, because it says check both equations, I'm going to do that. Checking the bottom equation is 4 equal question mark to 0 squared minus 2 times 0 plus 4, and I get 0 and 0, so I get 4 is equal to 4. That one works. And then the bottom equation, change colors again, for 1, 3 is 3 equal question mark to 1 squared minus 2 times 1 plus 4 is 3 equal question mark to 1 minus 2 plus 4. 1 minus 2 is negative 1, plus 4 is 3. So 3 is equal to 3, and that's true. So these both work. Okay, 31 is a circle and a line. Okay, I'm going to plug, again using substitution, plug this into this y, and I get x squared plus parenthesis 3x squared equals 10. Okay, simplifying this, x squared is plus. Now 3 squared is 9, and x squared is x squared equals 10. And then combining like terms, I have 10 x squared is equal to 10. Now I can divide both sides by 10. And I get x squared is equal to 1. Kind of go up here for more space. Now, at this point, there's two options you can go. You can subtract 1 from both sides and then factor a difference of squares. I've seen many students just kind of take square roots. If you take that route of taking square roots, you must know that it's x equals plus or minus 1. Okay? Because both positive and negative 1 squared they equal 1. Okay? So breaking that off, I have x is equal to positive and negative 1. If x equals negative 1, x equals positive 1, I need to find the corresponding y values. I can plug it in this bottom one, and I get 3 times that, so y would be equal to negative 3. And this one, y would be equal to positive 3. Okay, so the coordinates I get, I'll just keep it in red, is negative 1 comma negative 3 and 1 comma 3. It says check both equations. I know it works in the bottom because I just plugged it in there, but I'll check the top equation. So over here, I have negative 1 squared plus negative 3 squared. Does that equal 10? Well, I get negative 1 squared is 1. Negative 3 squared is positive 9, and that does equal 10. And then I'll check the second equation, which I think is very similar. 1 squared plus 3 squared, does that equal 10? And I get 1 plus 9, which does equal 10. Those both work. Okay? All right. And that's it. That's the whole thing. So if you made it this far, if you watched the whole video, then well done. Hopefully it helps you prepare for the exam. And good luck.